All right, let's get this started. Okay, hello everyone. Hope you're well and you're doing fine. Welcome to another 1203 lecture. So, nothing new to teach. So we finished everything I wanted to talk about in the course last time. So I figured today would be more or less a Q&A session. I know some people have been asking about solutions to the mock tests that I posted, and I didn't have time to write out the solutions given everything else I have to be taking care of right now. I have a couple classes taking the tests using Top Hat today, so I wanted to make sure all that stuff is set up. You guys are taking your test tomorrow during class time, during your regular class time. So if you are in the 10:30 class, then your exam starts at 10:30. If you're in the 11:30 class, your exam starts at 11:30. That being said, if it takes a while for people to get logged in, I'll start the exams like 10 or 15 minutes before the actual timing. But yeah, I have a lot of those exams going out today, so I was really focused on that. So what I wanted to do today is to maybe just have a Q&A session. If there's anything you guys would like to talk about more, or any questions you had from doing your review, I will just deal with those. And I think, and then tomorrow's class would be our test. So I figured that's what we could do today, because we're essentially done. So looking up our stuff here. So test 2. So for us, test 2 will involve evaluating integrals, including using substitution, including doing definite integrals, finding the average rate of a change of a function, using marginal function problems, right? So that's when I talk about like a demand function or a cost or revenue or profit, and ask you to find the marginal revenue and interpret what it means, things of that sort. Exponential growth and decay, related rates, optimization, and curve sketching, and the closed interval method. So that's what we have to cover. And you guys already have mock tests covering these things. Now, I don't think everyone did the online mock test yet, and that is open until 9 p.m. tonight. So hopefully you can get through that and just go through the whole process and figure out how to actually upload your solutions and all that good stuff. So I guess if there are any questions to ask from mock test, I probably only take those questions from the one that I have posted on the class website, because I want the people who haven't tried the online one to actually try those problems for themselves. Or maybe just any general questions about the concepts in the exam. So we'll start there. You guys shoot, go.
I have a question about the Top Hat. So I know yesterday it wasn't timed, like because you just had like an open window for us to take it.
Yeah, so it's definitely going to be timed tomorrow, if that's your question.
Will it have like a timer, or are we just gonna have to time ourselves?
Yeah, it should show a timer in one of the corners, so it should. Also, the exam will last the entire class session, so it's going to be open like 15 minutes before the class begins, but officially the clock starts when the class begins. So that's just a little buffer for any technical issues that you might have. If you have to like restart your computer or something, I'm giving you like a 15-minute buffer. It will continue until the end of the class session, so it will end like 10 minutes before the half hour. So for example, let's say you're in the 10:30 class. The exam starts at 10:30. However, I will open the exam at 10:15. The official start time is 10:30. The exam will continue until 11:20, and then you have until 11:30 to upload your answers. So I'm pretty sure there's going to be a timer, but just so you have an idea, it's the entire 50-minute session. So 11:20 is when you should stop the test, and then you have an extra 10 minutes to upload your answers. So hopefully that answers your question on timing.
I don't know if like 10 minutes was gonna be enough, because yesterday when I was trying to figure out how to upload it, they wouldn't take it because it was supposed to be a PDF, and when I scanned it, it's like a JPEG or whatever. So then I downloaded the app on my phone, and then
Yes.
I still couldn't like do it. But then I kept downloading and downloading, and then finally I changed it into a PDF, and that probably took more than 10 minutes. So.
I don't know, it should be very quick. So if you download the apps that I recommended that you download, I tested it myself and it doesn't take a long time at all. So a part of why you wasted it, it sounds like you didn't have that app in the first place and you scanned it to a picture and now you had to correct that. Get the apps that I recommended, it will scan to a PDF automatically and you just upload it. You can even upload it from your phone if you want to. So 10 minutes is definitely more than enough time. I was thinking of 5 minutes and I just decided to be nice and say 10 minutes. But it really is a quick process if you download the apps. So if you have an Android, I would say Genius Scan is the recommended app. If you have an iPhone, I would recommend, I forgot what that thing is, Scan. Scan. Do you guys remember? I don't have an iPhone, so I forgot the name.
I think it's called Scannable.
Scannable.
Yeah, it's Scannable by Evernote.
Yeah. And I have an Android. I tested out the Android version and it was actually pretty quick. I'm pretty sure 10 minutes is enough. And that's a part of why I want the online test and want you guys to practice so that you know how to do it. Because once you know how to do it, it should be quick. 10 minutes should be more than enough. Yeah. Any other questions?
I have a question about marginal functions.
Sure.
So when you are given the demand function and the cost function, how are you supposed to get the revenue function?
Okay, so the demand, how you want to think of the demand function is essentially like the price. So when you see demand function, think of that as price function. Right? And oftentimes, to be suggestive, it will be called P or P. Sometimes they call it big D, but I'll call it P. And so you think of that as the price. And so revenue is just price times number of items. And so if you're given a demand function, it's just going to be that demand function times X. So if I were to tell you, oh, the demand is P equals 50 minus radical X, then basically what that means is that your revenue function is going to be 50X minus X radical X. It's going to be X times the demand. So demand function, just think of that as someone telling you the price. When the price can change, it's different if the price is always the same, but sometimes price changes depending on how much you're selling. And so you would use a function to describe that, and it's called the demand function. So if you're given the demand and cost, from the demand you can figure out revenue, and from the revenue and cost you can figure out profit, because profit is revenue minus cost. So demand is price. Think of it as price. It's a function that gives you the price for X items. So you will have, so your demand, so you should know that demand is price. You can call that, say, P. And revenue equals P of X times X. Cost, we normally call that C of X And remember, your cost is given. So cost is not something you can figure out. Revenue is something you should be able to figure out. If you know the price, multiply by X, that's the revenue. And then profit, that's P, and that would be revenue minus cost. And when you hear marginal, it just means derivative for us. And it estimates the additional change from making one more. Specifically. So if you talk about marginal profit, so first of all, you should know how to find profit because it's using that equation. But then if someone says, what is marginal profit? Well, that just means you take the derivative of that profit function. And what this does, this is the additional, it's approximately the additional profit from selling one more item given X items were sold. Okay, so I think those are the main concepts in the marginal discussion. Demand is just another name for price. So whenever your price is varying, you measure it with a function. We call that the demand function. This is the function that tells you how much consumers are willing to consume, what price they're willing to pay for some commodity. Revenue is just the price times the number of items. Cost is going to be given because that's very specific to the situation of the particular business. And profit, that's something you can calculate. It's revenue minus cost. And marginal just means derivative. And in this context, it's used to estimate the additional change from one more. So marginal profit tells you what is the additional profit if I were to sell one more. Marginal revenue, what is the additional revenue if I were to sell one more? Marginal cost, what is the additional cost if I were to produce one more? So that's how you want to think of those. Other questions?
I have a question about related rates. So I know like in the mock test, you gave us the equation, like the volume or whatever it was given. Are you still going to be giving that, or like do we need to know what?
Oh, in general, you need to know. I'd only give you something if it's kind of a weird thing that you don't use all the time. But if I'm, for example, describing a rectangle and you need to somehow find the area, I'm not going to give you that formula. So I believe, I know, if it's something like the volume of a sphere or the volume of a cone, I'd give you that. But I think I'm going to describe a very simple geometric figure in your case. So I'm going to describe like a rectangle or a right triangle or a circle. And I would expect you to know all the formulas for that.
Are you allowed to go over a question from the mock test, or like do you not?
I can go over a question from the mock test, but I wouldn't want to do the online one because not everyone has seen it. Okay. But I would assume that at this point everyone has looked at the mock test that was on the class website. So if you have a question from that one, I can go over it.
I have one from the online one, the top hat, but it's okay. But can you go over a related rates problem that was from your worksheet that you gave us? It's number 7. It's similar to the one that's on the top hat, like in terms of
okay.
like talking about price.
Okay, hold on. Let me look it up. So it's actually was in the handout that I gave, the related rates handout.
Yeah, it's in the related rates number 7.
Okay, let me pull that up. Are you sure it's number 7? I don't think I gave you a problem like that. It wasn't with any price or demand function. You mean the ship sailing thing?
No, it was, I know it was question 5 on the one that was posted yesterday. It was about like volume, and it was like it's like the length is 2 times the width, and then it's like $6.
Oh, that's optimization.
Oh, that's the
That-
optimization.
That's not related rates. That's optimization. Do you mean optimization?
Yeah. Oh, yeah.
Yeah, that wasn't related rates. Optimization. Let's see, something similar to that problem.
It's like number 6 or number 5 on the optimization worksheet. Something with like dollars, just because that.
Yeah.
Confusing.
So 5 and 6 were like that, and I think the 6 on the would be similar. So an optimization problem 6. Okay, so that problem. So this is from optimization handout. Okay, so let's actually work through this one. Okay, so a storage shed is to be built in the shape of a box with a square base. It's to have a volume of 300 cubic feet. The concrete base costs that. The material for the roof costs that. The material for the sides costs that per square foot. So the cost is being assessed per area. Find the dimensions of the most economical shed. And then that last sentence is just an optional thing. It might come instead of me asking the other thing. Okay, so let's actually just answer the first question. Let's answer the question as if it ended right here. All right, so remember step 1, you'd read, right? So you'd recognize that it's an optimization. Step 2, you're going to look at a diagram. So here it's just the shape of a box. So I'll come out with a box. They said it has a square base. So I would label the base so. Whatever letter I use for the width, I use for that. The height we don't know, so I'd call that a different variable. Now, of course, this has a... Okay, so that's what we are using. And now, they talk about cost. So let's say cost for the floor. Okay, so it says the concrete base costs $8 per square foot. So the area of the floor, this is x times x, so this is 8x squared. So that's the cost. Then we're told the material for the roof costs $4 per square foot. So the roof cost is $4 per square foot. And again, the area of the roof is the x times the x, this length here times that length there, is 4x squared. Then it's like the material for the sides costs $5 per square foot. So here is the side. The cost is $5 per square foot. Now, if you look at the dimensions of the side, this is x times y. So the cost is 5xy. And there are 4 sides. So there's the front, the back, the left side, and the right side. So this has a cost of 20x squared for all 4 sides. So these are the guys that are important to me when I'm talking about cost. So I do my diagram and I kind of make sure I know everything in terms of that diagram. So I label it properly, label it carefully. And so the third step now is to come up with your constraint equation and your objective equation. Now the constraint is the thing that you're given. It's the restriction that you have. You do not have a choice in the constraint. Let me move the chat box out of the way here. you do not have a choice in the constraint. Now, if you read this, you'll realize here that the volume has to be 300 cubic feet, which means that can't be what you want. Volume here is your constraint. Volume has to be 300. And now you go to your diagram and you look, well, what would the volume of that be? And that's a form that I wouldn't give you. I would expect you to know what the volume of a box is. It's length times width times height. So that would be your constraint equation, the equation that describes your restriction, the given values. Now your objective is what you want to maximize or minimize. So now you realize that over here, it asks you to find the dimensions of the most economical shed. This tells you that cost is objective. You want to be most economical. So you want to know how to describe the cost here. Now, of course, the cost is just going to be the sum of all the costs. The cost of the roof plus the cost of the floor plus the cost of all four sides. So this is C is equal to 4x squared plus 8x squared plus 20xy. Or that means your cost is 12x squared plus 20xy. So that would be your constraint and your objective equation. Now, the fourth step is to solve for one variable in the constraint and plug it into the objective. You want to get the new objective. Your objective being in two variables is an issue in Calc 1, so we needed to get it in one variable. So you're going to solve for one variable here. Now, in general, the variable that you solve for here does not matter. Solve for the easiest one. If I were to solve for the x, I'm going to get a radical, so instead I'm going to solve for the y. So I can avoid the radical. And then I plug that into my objective. I can simplify that a little bit. The x's cancel. And so my new objective here is 12x squared plus 20 times 300 x to the minus 1. So that's the new objective. Fifth, you want to find technically it's the absolute min. But the endpoints aren't going to give you the answer here because that will give you 0. So what we're going to do is find the critical points, which means I need to talk about C prime. This is 24x minus 2300 x to the minus 2. Now, critical points are, of course, x equals 0 is a critical point because it divides by 0 here, and that would be where the derivative is undefined. But of course, I'm going to ignore this because if x equals 0, I won't have a box. But the other one is if this guy, 24x minus this guy is equal to 0. And so I want to solve that equal to 0. I can multiply both sides by x squared. Then solve for x cubed. So this is 20, 30 over 24. And what does that simplify to? I mean, 2 into this goes 12, 2 into that goes 10, 2 into this goes 6, 2 into that goes 5. 6 into this goes 1, 6 into that goes 50. So that's what, 250? Is that right? And so your x would be the cube root of 250, which I don't think that's a nice number. So I would leave it as cube root of 250. And at this point, we are on the final leg where we're going to answer the question. So the question asked us, what? Dimensions. So I'm specifically looking for dimensions. I know my x is the cube root of 250. My y is what I need because I need the height to talk about dimensions. And my y is 300 over x squared. So my y is going to be 300 over x squared. So that's 300 over and so the dimensions is length by width by height equals cube root of 250 by cube root of 250 by 300 over 250 to the 2/3. And that's probably feet. So that would be that. But of course, if you look on the handout where I gave this to you guys, these steps are there, and you pretty much just always go through those steps for any optimization problem. So step one is, of course, to read, because you don't want to mix these guys up with the related rates or anything else. There's a few word problems on your test. So you have to read, be able to recognize that it's an optimization. Once you do that, jump into a diagram, label it properly, make sure you interpret the question in terms of variables on that diagram. An important thing also here is to, if anything's a constant, label with a constant. If anything's a variable that you don't know, label with a variable. Third step is come with your constraint and objective equation. The constraint describes the restriction. So it is going to be something you're specifically given. In this case, the volume is 300 cubic feet. So that's your constraint equation. Your objective is what you want to maximize or minimize. In this case, we want to minimize cost because we are talking about the most economical shed. And so we have to figure out a way to do cost, which is coming from over here. You will always solve for one variable in constraint, plug into the objective to find the new objective. Then you're going to find the maximum or the minimum of that thing. If you have one answer, chances are that's the answer. If you have several answers, you like test it with the first derivative test or something. And then you answer the question. So whatever they ask for, give them that. And that leads us to the last sentence here. How would things change if the last sentence asked, what is the cost to build the most economical shed? So if the question was cost, then you don't need dimensions. Then the moment you solve for the x, you would just go back and plug it in up here, because once I know the x, I can just plug it in here to find the cost. But yeah, that's the optimization process in a nutshell. Every optimization problem is done the same way. The difference is just this is step 3, and I guess step 2. Step 2, what the diagram is going to look like, and step 3, setting up those equations, is what's going to change from question to question. But the process overall is going to be the same. You always do the same things in the same order. So.
I have a question about the first part of the question. Instead of using a cost function for the objective, can we use the formula for the surface area? And then whatever we get, which would be the dimensions, we just multiply it to find the cost?
No, because that would cause issues, because if it were the case that the cost is the same for all dimensions, like, oh, the cost of the floor and the roof and the sides are all the same, then yes. But the fact that the cost structure is different based on what you are, it's $4 per square foot over here, it's $8 per square foot over there. The difference in costs means you really need to separate things. So you don't want to find the total area first. You want to find the cost of each separate part first.
What if we just had to find the dimensions and not the cost? Could we use the surface area formula?
No, because cost is still going to be important, because we want to find the dimensions of the most economical shed. So cost is a part of it. You want the cheapest thing. And so you can't ignore the dollar signs, because the dollar, if you want to talk about what's cheaper, you need to know the dollar values of things. Like, so going through and ignoring the dollar value isn't going to work.
Okay, thank you.
It's a very different thing if, I don't know, I think that's the nail, man. Hold on, give me a second. Okay. All right, someone's gonna get it. All right, yeah, so the dollar value is important to the question here. So you don't want to be in a situation where you ignore the dollar value until too far.
I have a question regarding inflection points. So
Yes.
when you're finding the critical points for the second derivative of the function, and you see a difference, like when it goes concave up to concave down, like we know that's like an inflection point. So that,
yeah, if you're continuous there. So remember to check for that, right? So you can have an issue where, like, if there's an asymptote and your concavity changes on either side, then that still is an inflection point. But yes, assuming that point is on the graph, like it's a point that the curve passes through, when you switch concavity, that's inflection. But yes, continue.
so that point, do we plug it back into the original function to find the y value?
Yes, to
Okay.
find the coordinate, yeah. So if you're gonna graph it, you need the actual y coordinate. You always plug into the original function when you're looking for the coordinates.
Okay, thank you.
So you'll go through there, like this is step 4 in the curve sketching process. You'll go through the first derivative test. This will tell you about increasing, decreasing, and if there's any maximums and minimums. If you identify a point where you know it's a maximum, to find the coordinate, you plug into the original function, and that finds the coordinate of the maximum. Then when you go down to the concavity test and you find, oh, I know this point is an inflection point. Again, you go to the original to find the coordinate. So use the first and second derivative to identify the x value, but once you want to actually plot the location, yes, you always go back to the original equation.
Can you go over the integral problems on the mock test 2 that's on the website?
Sure. Let me... Mock test 2. So... All right, Okay, here's one of them. There's 2 of them. Boom. There's 3 of them. And I think this is the last one. Boom. There's 4 of them. Okay. Okay, so did anyone actually try these? Like, how would you attack the first one? Ideas.
Set ln to u.
Okay, so u equals ln of x. So your du would be 1 over x dx. And that's good because you kind of see the 1 over x dx right here. Right? So that's what makes you think, hey, that would be a good substitution. Right? So looks complicated, you don't have a rule for that, but you can pick this thing And when you differentiate it, you get something similar. So what you do is you solve for the dx, this will be x du, and then you go and you plug that into the integral. So your ln of x is u, so that's u squared, over 2x, didn't change, and your dx is now x times du. Now your x's cancel, and you can factor out this 2, so the 1/2 comes out, and you just have u squared du. And then now that's easy, that's just the power rule. So it's u cubed over 3 plus c. So that's u cubed over 6 plus c. And then you just actually plug in the ln back. So substitution. Questions on this one from anyone? Do you get what I did? Me. I guess so. Attempts on this?
U equals x squared plus 8x.
U equals x squared plus 8x. Your du would be 2x plus 8 du dx. Okay. You can notice that that is 2 times x plus 4 dx. And again, you kind of notice the x plus 4 dx with that guy, right? So if you're doing these guys and you're getting a function where you don't see it, you're probably doing the wrong substitution. Not that that's true in general. The moment you get to Calc 2, that's no longer true. The integrals can get a lot more complicated. But in the Calc 1 version, whenever there's a substitution problem, you should be able to find the function part somewhere else in the function. Now, if you're off by a constant, it doesn't matter because you can always divide those out. But again, we are going to just solve for the dx. So solving for dx, we would get du over 2x plus 4. And then now I plug that into the integral. So I have the x plus 4 over my x squared plus 8 was u, so that's u cubed in the denominator. And my dx is just this guy, du over 2 times x plus 4. And the x plus 4's cancel. And that 2 over here, I can factor out. It's again a half. And so the integral is 1 over u cubed. And now that's a lot simpler. How would you integrate 1 over u cubed? Ideas?
1 over 2 u squared. Negative 1 over u.
How are you getting that?
Well, I know the denominator would be u squared. So 1/2 u squared, but in the denominator. Because that'd have to be negative 2.
Okay. So you just did that in your head because you know it's the pattern, or?
Yeah, yeah. I don't really, I just
Okay. Maybe someone else, something we can follow?
Would it be negative 1 over 2 times u squared?
Yeah, you're just giving me the answer. Tell me how to figure it out. You're both giving me the answer. Like, so you
So
guys see
the-
it, but it's possible for someone to not see it. So how would you describe it to your friend who, I don't
Would
see
be-
why that would be the answer.
u in the numerator be u negative 3 plus 1 over negative 3 plus 1.
Right, so the first thing is to write it as that. and then use the power rule, because you know a rule that does this. Right, so you know that rule. We didn't really have a rule for 1 over x to a number. So you just move it up, then you add 1 to the power and divide by the new power. And so that's where the minus a half 1 over u squared comes from. So that's correct, but not everyone is going to see that right off the bat. So rewrite it. You always want to rewrite things so that they look like a rule that you have. So this just becomes minus a quarter u to the minus 2. And you can just now plug that in. So your u was x squared plus 8x. So we have that. Okay, ideas for this one?
Don't they distribute across some? So you could do 1 over x cubed plus x squared over x cubed.
So this will be x to the minus 3, and that would be 1 over x. All right, then?
I would like separate the two. So
Mhm.
like integral of from e to 1 of x to the negative third plus integral of.
Yeah, I don't, it's not necessary to actually write that out, but yes, you can imagine just doing these separately. But given that that's what we're doing.
And then the integral of x to the negative 3 is x to the negative 3 plus 1 over negative 3 plus 1. And then bracket like e to 1.
Yeah, what is the integral of this?
ln x.
ln of absolute value of x.
Yeah.
Between 1 and e. So now you just plug in the e. Minus, plug in the 1. And these guys you should know. What's ln of e?
1.
ln of e is 1. What's ln of 1?
0.
0. So then this just becomes, you have minus 1 over 2e squared, and then plus a half. So that's fine. So that's that one. And there are various ways you can write that answer down. You could leave it as e to the minus 2 over 2 minus 2, and it's fine.
For that one, wouldn't it be negative 1 over 2 e squared plus 3 over 2? Because it's the 1
I got that too.
1/2.
Huh?
For
Where?
that one,
Oh, the 1. We forgot that 1. Yeah. So there is actually a plus 1 here. Right? Yeah. You guys are going to do better than I would on that test tomorrow. Awesome. What about this one?
U equals x squared plus x plus 1.
this thing's messing up again. Anyway, that would cancel. And you'd have u to the 4th du, u to the 5th over 5 plus c. And our u was x squared plus x plus 1. Okay. Hold on, let me restart here because sometimes this thing misbehaves. Okay, there we go. All right, how about this one?
You can set u to x to the 3rd plus 1.
Okay. Now what?
So now it would be du over 3x squared equals dx.
Okay, so we go down and we plug this in. That's our u here. And this is du over 3x squared. Now what?
Can you?
Now, yeah.
Oh, I'm not sure if this is right. Can you separate the 1? So can you pull out the 1 and then? So it would be. So that would just be 3x squared, and then you would cancel that with the.
Where would I put the 1?
Outside of the integral. I'm not sure. So
Nope, because it's being added.
Right. What if you do two separate integrals? So integral of 3x squared plus 1 and then integral of u to the u squared. Can you do that?
No. Integrals don't distribute across products. So if you have like f of x times g of x and you have an integral, it's not the same as just integrating the f and then integrating the g.
Okay.
So this is a trick. It's kind of a fake out.
Yeah,
Substitution is not how you want to go here because you'll realize you won't be able to cancel the thing.
Yeah.
The derivative, and again, remember, this is just a thing you have to watch out with substitution. The derivative, you need to be able to find it somewhere else. The fact that your derivative here gives you a 3x squared, and over here you have a 3x squared plus 1, that's kind of indicates to you that substitution is not going to work. The better way here is to actually 3x squared plus 1 x cubed plus x cubed plus 1 squared dx. So you see something like this, it's kind of a fake out. It would be the kind of problem where that would catch someone who isn't really paying attention to the integration by substitution idea. You realize that your substitution is going to work. It's better here to just actually just brute force things. So first square that. then multiply these guys out. So take the 3x squared, multiply everybody. Get 3x to the 8 plus 6x to the 5th plus 3x squared. Then take the 1, multiply everybody. X to the 6 plus 2x cubed plus 1. And just using the power rule on everybody. So this is x to the 9th over 9, which cancels into the 3. This is the x to the 6. This is going to be x cubed. This is going to be x to the 7 over 7. This is going to be x to the 4th over 2. And this is going to be x. So it was a fake out. Be careful. So the step in the substitution, very important. After you choose something to be a substitution, to make your life easier, you need to make sure that when you take the derivative actually plays nicely with what you had in the original. So here I took the derivative, hey, that x plus 4, I see that x plus 4 here. Hey, I took this derivative, that 1 over x, I see that 1 over x here. Here we didn't need a substitution. Here you took the derivative and then you notice here, oh, that 2x plus 1, I noticed that here. Here's that 2x plus 1 dx right there. So that's very important. You go through here, try to do a substitution, you realize the substitution isn't going to work out for you. And you don't want to get to this point before you actually realize that. You should have realized that way up here. Right? How am I going to get that 3x squared? Because now I have a 3x squared plus 1. And if the constant was multiplying, I can factor it out. I know that. But with the plus, that's a problem. So that kind of tells you I have to now expand something. And if you're going to expand, you might as well have done it from the beginning. Just expand it from the beginning. So. I mean, at this point, a problem like that, and I don't even know I'm going to put it on, but I have put problems like this on tests before, so that's why I'm bringing it up. But this is like the most tricky kind of thing that would be out there. It's something where it's like a substitution can almost work, but it's not quite right. And I'm just checking to see, do they recognize that the substitution isn't quite right here? There's something that's off. And you're supposed to recognize, hey, there's something off here, and go with another plan. But these here, for the most part, they're kind of straightforward if you went through the lecture and did a bunch of problems. But yeah, and we're actually over time, so want to wrap up now. I guess you guys might have other classes to go to. So maybe any quick parting question, we can wrap up here. So as just to, I don't remember if I said this, but remember your test is tomorrow during regular class time. It will start 15 minutes before the class actually starts. So if you have a 10:30 class, you should be able to access the test as of 10:15. But the official start time, it would be the 10:30. It will continue to the end of the class period, which is 11:20. And then you have an extra 10 minutes to upload your stuff. If you use the recommended apps that I mentioned, uploading should be quick. You should be able to get that done in less than 5 minutes. But remember the instructions for actually uploading, one problem number per page. So you do problem 1 on a page, problem 2 on a page, problem 3 on a separate page, and you scan them in order and upload it. And yeah, I think that's it. We got through a hefty amount of topics here. Hopefully that sets you guys up for tomorrow. Any other parting questions?
For the questions with like optimization, if we get like a weird radical answer, are we allowed to use a calculator to get the actual value?
No, just leave it like that.
Okay.
Yeah. All right. That being said, let's wrap up there. As always, I'll post a video to this in a little bit with the PDF here. And as far as that is concerned, we are done. Good luck. I will see you guys tomorrow. And yeah, bye. Stay safe. Keep studying. Try the online mock test. Make sure you can do that. And I will see you guys in the next one. All right.